Hello guys, welcome to Apna Commerce Club. I am Rimsha Batool and I will be teaching you how to solve questions of business maths of CA Foundation. So today we'll be solving the additional question bank that is there behind chapter number 1 in the ratios, proportions, indices and logarithms. There are 109 questions. Let's begin. So question number 1. The value of 6 to the power minus 1 into 7 to the power 2 divided by 6 square into 7 to the power minus 4 the whole to the power 7 divided by 2 into 6 to the power minus 2 into 7 to the power 3 the whole divided by 6 to the power 3 into 7 to the power minus 5 the whole to the power minus 5 by 2 is. So for this, first we'll apply the property 1 divided by a to the power x. This can be written as a to the power minus x. So applying that property, we'll get 6 to the power minus 1. This 6 square, I'm bringing it to the numerator into 6 square into 7 square. And this 7 to the power minus 4 in the denominator, I'm bringing it to the numerator. When you bring a power to the numerator, the sign in the power changes. So 7 square into 7 to the power minus 4 becomes 7 to the power 4. The whole to the power 7 divided by 2 into this will be 6 to the power minus 2 and the 6 to the power 3 I am bringing it to the numerator. So it will become 6 to the power minus 3 into 7 to the power 3 and the 7 to the power 5 I am bringing to the numerator and it will become 7 to the power 5. The whole to the power minus 5 by 2. Now next I am using this property a to the power x into b to the power y is equal to a to the power xy. Now here the bases are same, 6 and 6. So the powers can be added. This will become 6 to the power minus 3 into 7 to the power 6, the whole to the power 7 divided by 2 into 6 to the power minus 2 and minus 3 will become minus 5 into 7 to the power 8, the whole to the power minus 5 by 2. This 7 divided by 2 I am multiplying with these powers. So you will get 6 to the power minus 3 into 7 divided by 2 into 7 to the power 6 into 7 divided by 2 into 6 to the power minus 5 into minus 5 divided by 2 into 7 to the power 8 into minus 5 divided by 2. Now this will become 6 to the power minus 3 into 7 will become 21. Minus 21 divided by 2 into this 7 to the power, this 6 and 2 we can cancel. So 2 3s are 6. You will get 3 7s are 21 into 6 to the power minus 5 into minus 5 will become plus 25. So 25 divided by 2 into 7 to the power. This 8 and 2 we can cancel. You will get 2 4s are. So 4 into minus 5 you will get minus 20. Now this 6 and 6 I am writing it together and the 7 and 7 I am writing it together. So you get 6 to the power minus 21 divided by 2. Now if the bases are same, the powers can be added. So this 6 power and this 6 power I am adding it. Plus 25 divided by 2 into 7 to the power 21 and this 7 has minus 20 as a power which I am adding it. So here you will get 6 to the power 4 divided by 2 into 7 to the power 1. This 2 and 4 will get cancelled. You will get 6 to the power 2. 6 to the power 2 into 7, which is equal to 36 into 7. If you multiply, you will get 252 as the answer. Number B. So option number B is the correct answer. Moving on to question number 2. X to the power 2 divided by 7, the whole divided by z to the power minus 1 by 2 into x to the power 2 divided by 5 divided by z to the power 2 divided by 3 into x to the power minus 9 by 7 divided by y to the power 2 by 3 into z to the power 5 by 6 divided by x to the power minus 3 by 5. Here I am bringing all the terms in denominator to the numerator. When you do that, the sign will change in the power. So this will become x to the power 2 by 7 into y to the power minus 1 by 2 will become 1 by 2 into x to the power 2 by 5 into z to the power, this is z, z to the power 2 by 3. When it comes to the numerator, it will become minus 2 by 3 into x to the power minus 9 by 7 into z to the power minus 2 by 3. 2 by 3 when it comes to the numerator will become minus 2 by 3 into z to the power 5 by 6 into x to the power 3 by 5. Now all the x terms, I am writing it together. And all the z terms, I am writing it together. So you will get x to the power 2 by 7 into x to the power 2 by 5 into x to the power minus 9 by 7 into x to the power 3 by 5 into all the z terms, I am writing it together. Z to the power 1 by 2 minus, z to the power minus 2 by 3 into z to the power again minus 2 by 3 into z to the power 5 by 6. Now all the bases are same here, so the powers can be added. X to the power 2 by 7 plus 2 by 5 minus 9 by 7 plus 3 by 5. Here again all the base is same, so I can write it as z to the power 1 by 2 minus 2 by 3 minus 2 by 3 plus 5 by 6. Now we'll take LCM. For this, we'll get LCM as 35. So x to the power, here in the denominator we'll get 35. So this 2 you will multiply by 5 because the denominator is 7 and you multiply it by 5 to get 35. So this will be 10 plus this 2 you multiply by 7. So you'll get 14 minus this 9 will multiply by 5. So you'll get 45 plus this 3 will multiply by 7, 21 into z to the power. Here you will get LCM as 6. So this will become 3 minus 4 plus 5. Now if you add all the terms, you will get 0. You will get 0 divided by 35, which is 0. So x to the power 0 and this side too, z to the power, when you add everything, you will get 0 divided by 6. So that will also become 0. So anything to the power 0 is 1. So this is 1 into 1. Answer is 1. Option number A. So option number A is the correct answer. Moving on to the next question. Question number 3. 2 to the power x plus 3 into 3 to the power 2x minus y into 5 to the power x plus y plus 3 into 6 to the power y plus 1, the whole divided by 6 to the power x plus 1 into 10 to the power y plus 3 into 15 to the power x. Now these powers I am writing it separately. So this will become 2 to the power x into 2 to the power 3 into 3 to the power 2x into 3 to the power minus y into 5 to the power x into 5 to the power y into 5 to the power 3 into 6 to the power y into 6 to the power 1. The whole divided by 6 to the power x into 6 to the power 1 into 10 to the power y into 10 to the power 3 into 15 to the power x. Now whichever term has a variable in the power, I am writing those separately. So 2 to the power x and then this 3 to the power 2x and then 5 to the power x and 5 to the power y and 6 to the power y. Here in the denominator, this 3 to the power minus 1, I am bringing it to the denominator because there is a minus in the power. So it will become reciprocal. This will become 3 to the power y and this 6 to the power x, 10 to the power y and 15 to the power x. Now all the other terms I am writing it separately. So 2 to the power 3, I am writing it as 2 into 2 into 2 into 5 to the power 3, I am writing it as 5 into 5 into 5 and then 6 to the power 1. In the denominator we have 6 to the power 1 and then 10 to the power 3, which I am writing it as 10 into 10 into 10. So this we can cancel. 5 2s are, so 2 1s are and 6 1s are. Now here, all these terms, I am taking the base as either 2 or 3 or 5. So this 2 to the power x into 3 to the power 2x into 5 to the power x into 5 to the power y. This one I am writing it as 2 to the power y into 3 to the power y, which is nothing but 6 to the power y. The whole divided by 3 to the power y into this 6 to the power x, I am writing it as 3 to the power x into 2 to the power x into 10 to the power y, I am writing it as 5 to the power y into 2 to the power y into 15, I am writing it as 5 to the power x into 3 to the power x. Now we can cancel 2 to the power x and 2 to the power x, 3 to the power 2x and here 3x, 3 to the power x. 5 to the power x and 5 to the power x gets cancelled. 5 to the power y, 5 to the power y, 2 to the power y, 2 to the power y and 3 to the power y, 3 to the power y. So everything gets cancelled. The answer is 1, which is option number C. Okay, so here the correct answer is option C. Now moving on to question number 4. 9 to the power y into 3 square into 3 to the power minus y, the whole to the power minus 1, minus 27 to the power y, the whole divided by 3 to the power 3x into 2 to the power 3 is equal to 1 divided by 27. Here I am taking the base as 3, So this I'm writing it as 3 to the power 2, which is nothing but 9. And there is a y in the power already. So this will become 3 to the power 2y into 3 to the power 2. Here this 3 to the power minus y and minus 1 I can multiply this by using this property. A to the power x, the whole to the power y becomes a to the power xy. So by using that property, this will become 3 to the power minus y into minus 1 will become y. Minus 3, this I'm writing it as 3 to the power 3, which is nothing but 27. And there is a y in the power. So 3 to the power 3y. The whole divided by 3 to the power 3x. And 2 to the power 3 is 8. So into 8 is equal to, this I'm writing it as 1 divided by 3 to the power 3, which is 27. Now, in these terms, when the base is common, the powers can be added. So, this will become 3 to the power 2y plus 2 plus y minus 3 to the power 3y. The whole divided by 3 to the power 3x into 8. Here 1 divided by 3 to the power 3. Now this 2y and y can be added. So it will become 3 to the power 3y plus 2 minus 3 to the power 3y. The whole divided by 3 to the power 3x into 8. This side is equal to 1 divided by 3 to the power 3. Now in the numerator, we'll take out whatever is common. So 3 to the power 3y is common. If we take it out, we are left with 3 to the power 2 minus 1 divided by 3 to the power 3x into 8 is equal to 1 divided by 3 to the power 3. So 3 to the power 3y and 3 square is 9. So 9 minus 1 divided by 3 to the power 3x into 8 is equal to 1 divided by 3 to the power 3. This will become 3 to the power 3y into 8 divided by 3 to the power 3x into 8 is equal to 1 divided by 3 to the power 3. 8 and 8 will get cancelled. Now whatever term we have in the denominator, I'm bringing it to the numerator. So this will become 3 to the power 3y into 3 to the power minus 3x. When you bring a term to the numerator, the sign changes in the power, which is equal to 3 to the power minus 3. So since the base is same, the powers can be added. This will become 3 to the power 3y minus 3x is equal to 3 to the power minus 3. Now here I am taking 3 common outside in the power. So you will get 3 to the power 3 into y minus x is equal to 3 to the power minus 3. Now here both the sides, the base are same and it is equal to each other. So the powers are also equal to each other. So taking only the power, I will get 3 into y minus x is equal to minus 3. This 3 and 3 will get cancelled. So y minus x is equal to minus 1. Now bringing the minus 1 to this side and y minus x to this side, we'll get 1 is equal to x minus y. This is what they've asked in the question, to find x minus y. So the answer is 1. Option number B. So for the fourth one, the correct option is B. Moving on to the fifth one. X to the power 1 divided by a minus b into 1 divided by a minus c into x to the power 1 divided by b minus c into 1 divided by b minus a into x to the power 1 divided by c minus a into 1 divided by c minus b. The powers are multiplying, so you will get x to the power 1 divided by a minus b into a minus c into x to the power 1 divided by b minus c into b minus a into x to the power 1 divided by c minus a into c minus b. Now in the powers, wherever there is 1 minus c, I'm changing it as minus bracket c minus a. And wherever there is b minus a, I'm writing it as minus a minus b. And wherever there is c minus b, I'll be writing it as minus of b minus c. So you'll get x to the power 1 divided by a minus b minus of c minus a into x to the power 1 divided by b minus c into minus of a minus b into x to the power 1 divided by c minus a into minus of b minus c. So you'll be getting 1 divided by a minus b into c minus a. This minus, I'm taking it here. So similarly into x to the power 1 divided by b minus c into a minus b. This minus, I'm taking it here. Into x to the power 1 divided by c minus a into b minus c, and minus, I'm taking it here. Now all the bases are same. We have x here. So I'm taking the common base as x and I'm adding the powers. So if I add it, I'll be getting minus 1 divided by 1 minus b into c minus a minus 1 divided by b minus c into a minus b minus 1 divided by c minus a into b minus c. Now taking the LCM for the denominator, you'll get a minus b into b minus c into c minus a as the LCM. So whichever term is missing in the denominator, you will multiply that term in the numerator. So in this one, b minus c is missing. So this minus, I'm writing it and multiplying it by b minus c. And for the second one, c minus a is missing in the denominator. So multiplying it by c minus a. And then minus. In the third one, a minus b is missing in the denominator. So multiplying the numerator by a minus b. Now removing the brackets, we'll get minus b, minus into minus plus c, minus c, and minus into minus plus a, minus a, and minus into minus plus b. So whole divided by a minus b b minus c, and c minus a. So plus b and minus b will get cancelled. C minus c and a minus a. We'll get x to the power 0, which is 1. Option number A. So question number 6. 16 into 32 to the power x minus 2 to the power 3x minus 2 into 4 to the power x plus 1, the whole divided by 15 into 2 to the power x minus 1 into 16 to the power x minus 5 to the power 1 into 5 to the power x minus 1 divided by root of 5 to the power 2x. Here I'm changing the base of everything to 2. So 16 I can write it as 2 to the power 4 into 32 I'm writing it as 2 to the power 5, and there is an x in the power. So this will become 5x minus 2 to the power 3x minus 2 into 4 I'm writing it as 2 to the power 2 into x plus 1, the whole divided by 15 into 2 to the power x minus 1 into 16 I'm writing it as 2 to the power 4x minus, here the bases are same, so the powers can be added. So this will become 5 to the power 1 plus x minus 1 divided by root 5 to the power 2x. Root is nothing but to the power 1 by 2. So this I can write it as 5 to the power 2x to the power 1 by 2. This 2 and 2 will get cancelled. Here the bases are same, 2 and 2. So the powers can be added again. So 2 to the power 4 plus 5x minus, here again the bases are same. So I'm writing it as 2 to the power 3x minus 2. This I'm multiplying 2 into x and 2 into 1. So this will become plus 2x and plus 2. The whole divided by 15 into, here 2 and 2 again the bases are same. So the powers can be added, 2 to the power x minus 1 plus 4x. Here plus 1 and minus 1 will get cancelled. So you're left with 5 to the power x. In the denominator also 5 to the power x. So 5 to the power x and 5 to the power x will get cancelled. So you're left with 1. Here in the power minus 2 and plus 2 will get cancelled. So you're left with 2 to the power 5x plus 4 minus 2 to the power 3x plus 2x will become 5x divided by 15 into 2 to the power x plus 4x will become 5x minus 1 minus 1. Here I am taking 2 to the power 5x common in the numerator. So 2 to the power 5x, you are left with 2 to the power 4 minus 1. The whole divided by 15 into 2 to the power 5x minus 1 minus of this will become 2 to the power 5x. 2 to the power 4 is 16 and 16 minus 1 is 15. So 15 divided by 15 into 2 to the power 5x minus 1 minus 1. 15 will get cancelled. So here I am left with 2 to the power 5x. This 2 to the power 5x minus 1 in the denominator, I am bringing it to the numerator. So into 2 to the power, the sign will change in the power. So this will become minus 5x plus 1 and minus 1. Here 2 and 2, the base is same, so the powers can be added. So this will become 2 to the power 5x minus 5x plus 1 minus 1. 5x and minus 5x will get subtracted. So this is 2 to the power 1 is 2 minus 1, which is equal to 1. The answer is 1. Option number A. Sixth one, option A is the correct answer. Now moving on to the seventh one. X to the power A divided by x to the power B, the whole to the power A plus B into x to the power B divided by x to the power C, the whole to the power B plus C into x to the power C divided by x to the power A, the whole to the power C plus A. This, the x powers, I am bringing it to the numerator. So this will become x to the power A into x to the power minus b. When I bring a term to the numerator, the sign will change into a plus b. Here x to the power b into x to the power minus c, the whole to the power b plus c into x to the power c into x to the power minus a, the whole to the power c plus a. Now the bases are same here, so the powers can be added. This will become x to the power a minus b and this a plus b into x to the power. The powers again can be added. So b minus c into b plus c into x to the power c minus a into c plus a. Now the powers are in the form of a plus b into a minus b, which is the formula for a square minus b square. So by applying that formula in the power, we'll get x to the power a square minus b square into x to the power b square minus c square into x to the power c square minus a square. Now again the bases are common, x, and x, so the powers can be added. So if you add the powers, you'll get x to the power a square minus b square plus b square minus c square plus c square minus a square. So a square and minus a square will get subtracted, b square and minus b square, and c square and minus c square. So you're left with x to the power 0, which is equal to 1. Option number D. So the correct answer is D for 7th one. Now question number 8. X to the power a square divided by x to the power b square, the whole root of a plus b into x to the power b square divided by x to the power c square, the whole root of b plus c into x to the power c square divided by x to the power a square, the whole root of c plus a. This can be written as x to the power a square divided by x to the power b square, the whole to the power 1 divided by a plus b into x to the power b square divided by x to the power c square, the whole to the power 1 divided by b plus c into x to the power c square divided by x to the power a square, the whole to the power 1 divided by c plus a. Now after this, I'm bringing the denominator to the numerator. So this will become x to the power a square into x to the power minus b square. So the sign will change in the powers. The whole to the power 1 divided by a plus b into x to the power b square into x to the power minus c square, the whole to the power 1 divided by b plus c into x to the power c square into x to the power minus a square, the whole to the power 1 divided by c plus a. Now the bases are same, so the powers can be added. So x to the power a square minus b square, the whole to the power 1 divided by a plus b into x to the power b square minus c square, the whole to the power 1 divided by b plus c into x to the power c square minus a square, the whole to the power 1 divided by c plus a. Now I'm multiplying the powers. So after multiplying, you get x to the power a square minus b square divided by a plus b into x to the power b square minus c square divided by b plus c into x to the power c square minus a square divided by c plus a. Now here a square minus b square, I am applying the formula, which is a plus b into a minus b divided by a plus b. Here a plus b and a plus b will get cancelled. Here into, again applying the formula, I'll get b plus c into b minus c divided by b plus c. B plus c and b plus c will get cancelled. And here x to the power c plus a into c minus a, the whole divided by c plus a. C plus a and c plus a will get cancelled. So we are left with x to the power a minus b into x to the power b minus c into x to the power c minus a. Now again the bases are same, so the powers can be added. So x to the power a minus b plus b minus c plus c minus a and minus a plus b and minus b plus c and minus c will get cancelled. So you'll get x to the power 0, which is equal to 1. Option number A. So option A is the correct answer. Now question number 9. X to the power b plus c divided by c minus a, the whole to the power 1 divided by a minus b into x to the power c plus a divided by a minus b, the whole to the power 1 divided by b minus c into x to the power a plus b divided by b minus c, the whole to the power 1 divided by c minus a. This is the question. Now first, let's multiply the powers. So after multiplying, you'll get x to the power b plus c divided by c minus a into a minus b. Here you'll get x to the power c plus a divided by a minus b into b minus c. And here x to the power a plus b divided by b minus c into c minus a. Now since the bases are same, x, and x, the powers can be added. So this can be written as x to the power b plus c divided by c minus a into a minus b plus c plus a divided by a minus b into b minus c plus a plus b divided by b minus c into c minus a. Now if you take LCM, you will get in the denominator, you will be getting a minus b into b minus c into c minus a. And in the numerator, you will multiply whichever term is missing in the denominator. So in this one, the term that is missing is b minus c. So this b plus c, you will multiply by b minus c plus here this c plus a, write it as it is. And in the denominator, c minus a is missing. So multiply it by c minus a. Here plus a plus b. And here a minus b is missing in the denominator. So multiply the numerator by a minus b. Now here in the numerator, the formula can be applied. B plus c into b minus c. Applying a square minus b square formula, you will get b square minus c square. Here again, c plus a into c minus a will become c square minus a square plus a plus b into a minus b is a square minus b square. The whole divided by a minus b into b minus c into c minus a. So here b square and minus b square will be cancelled. Minus c square and c square will get cancelled, and minus a square and a square will get cancelled. So the numerator becomes 0. So it will become x to the power 0, which is equal to 1. Option number A. So for the ninth one, option A is the correct answer. Now question number 10. X to the power b divided by x to the power c, the whole to the power a into x to the power c divided by x to the power a, the whole to the power b into x to the power a divided by x to the power b, the whole to the power c. Here the denominators I'm bringing it to the numerator. By doing so, the sign and the powers will change. So it will become x to the power b into x to the power minus c, the whole to the power a, into x to the power c into x to the power minus a, the whole to the power b, into x to the power a into x to the power minus b, the whole to the power c. Now since the bases are same, the powers can be added. So this will become x to the power b minus c, the whole to the power a. into x to the power c minus a the whole to the power b into x to the power a minus b the whole to the power c. Now multiply the powers together. A into b and a into minus c. This is b into c and b into minus a. And here c into a and c into minus b. So you'll get x to the power ab minus ac into x to the power b into c minus ab into x to the power ac minus b into c. Here again the bases are same, so the powers can be added. We'll get x to the power ab minus ac plus b into c minus ab plus ac and minus b into c. ab and minus ab minus ac and plus ac and plus b into c and minus b into c will get cancelled. So you'll get x to the power 0, which is equal to 1. Option A. So for the 10th one, option A is the correct. Moving on to 11th one. X to the power b divided by x to the power c the whole to the power 1 divided by b into c into x to the power c divided by x to the power a the whole to the power 1 divided by ca into x to the power a divided by x to the power b the whole to the power 1 divided by ab. Here again, the denominator I'm bringing to the numerator. So the sign in the powers will change. So this will become x to the power b into x to the power minus c the whole to the power 1 divided by b into c into x to the power c into x to the power minus a the whole to the power 1 divided by ca into x to the power a into x to the power minus b the whole to the power 1 divided by ab. Now since the bases are same, the powers can be added. So this will become x to the power b minus c the whole to the power 1 divided by b into c into x to the power c minus a the whole to the power 1 divided by ca into x to the power a minus b the whole to the power 1 divided by ab. Now I'm multiplying the powers, which is inside the bracket and outside the bracket. So after multiplying, we'll get x to the power b minus c divided by b into c into x to the power c minus a divided by ca into x to the power a minus b divided by ab. Now since the bases are same, again I'm adding the powers. So I'll get x to the power b minus c divided by b into c plus c minus a divided by ca plus a minus b divided by ab. Now if you take LCM for this, you will get in the denominator, you will get a into b into c. So whichever term is missing in the denominator, you will multiply that term in the numerator. Here in the denominator, a is missing. So you will multiply it by a into b minus c plus here b is missing, b into c minus a plus here c is missing. So c into a minus b, the whole divided by abc. So multiply it, a into b and a into minus c, b into c and b into minus a, and c into a and c into minus b. You will get x to the power ab minus ac plus b into c minus ab plus ca minus b into c, the whole divided by a into b into c. So here ab and minus ab minus ac and plus ac plus bc and minus b into c will get cancelled. So we are left with x to the power 0, which is 1. Option C. Now, question number 12. X to the power a divided by x to the power b, the whole to the power a square plus ab plus b square into x to the power b divided by x to the power c, the whole to the power b square plus b into c plus c square into x to the power c divided by x to the power a, the whole to the power c square plus ac plus a square. Now here I am bringing the denominator to the numerator. So this will become x to the power a into x to the power minus b. When I bring it to the top, the sign will change in the power. So b will become minus b, the whole to the power a square plus ab plus b square into x to the power b into x to the power minus c, the whole to the power b square plus b into c plus c square into x to the power c into x to the power minus a, the whole to the power c square plus ac plus a square. Now here the bases are same, so the powers can be added. So this will become x to the power a minus b into a square plus ab plus b square into x to the power b minus c into b square plus b into c plus c square into x to the power c minus a into c square plus ac plus a square. Now, we know the formula for a cube minus b cube, which is equal to a minus b into a square plus ab plus b square. Using this formula, apply this formula to the powers. Since all the powers are in the same form, we'll get x to the power a cube minus b cube into x to the power b cube minus c cube into x to the power c cube minus a cube. Now again the bases are same, so the powers can be added. So this will become x to the power a cube minus b cube plus b cube minus c cube plus c cube minus a cube. So a cube and minus a cube, b cube and minus b cube, and c cube and minus c cube will get subtracted. So you will get x to the power 0, which is equal to 1. Option C. Now question number 13 is given, show that 2 to the power x plus y is equal to 4 into 8 into 16. Then x plus y the whole square is equal to. So here the question is given 2 to the power x plus y is equal to 4 into 8 into 16. So 2 to the power x plus y, this I'm multiplying, 4 into 8 into 16 will give us 512. Now 2 to the power x plus y is equal to this 5 and 12, I'm writing it as 2 to the power 9. 2 to the power 9 is 512. Now the bases are same and it is equal to each other. Applying the property a to the power x is equal to a to the power y. If the bases are same and it's equal to each other, then the powers are also equal to each other. So if you apply that property, we'll get x plus y is equal to 9. Now in the question they are asking us to find x plus y the whole square, which is equal to 9 square, which is equal to 81. option B. So 13th one is option B, 81. Now question number 14. X to the power B divided by x to the power C, the whole to the power B plus C minus A into x to the power C divided by x to the power A, the whole to the power C plus A minus B into x to the power A divided by x to the power B, the whole to the power A plus B minus C. Here the denominators I'm bringing to the numerator, so the powers, the sign of the powers will change. So this will become x to the power B into x to the power minus C, the whole to the power B plus C minus A. And this will become x to the power C into x to the power minus A, the whole to the power C plus A minus B. This will become x to the power A into x to the power minus B, the whole to the power A plus B minus C. Now, since the bases are same, the powers can be added. So this can be written as x to the power B minus C into B plus C minus A. And this can be written as x to the power C minus A into C plus A minus B. And this x to the power A minus B into A plus B minus C. Here I'm multiplying, I'm removing the brackets and multiplying it. So B into B and B into C and B into minus A and minus C into B and minus C into plus C and minus C into minus A. So if we do that, we'll get x to the power B square plus B into C minus B into minus A is minus AB. Then we'll get minus C into B, then minus C square plus AC into here x into C, and C will get C square plus C into A, AC minus C into minus B is B into C, and minus A into C is minus AC, and minus A into A square, and plus AB. And then the third term into x to the power A square plus AB minus AC minus AB minus B square and plus B into C. Here plus B into C and minus B into C can be subtracted, and plus AC and minus AC can be subtracted, plus AB and minus AB can be subtracted. Now the bases are same, x into x into x, so all the powers can be added together. So we'll get x to the power B square minus AB minus C square plus AC plus C square minus B into C minus A square plus AB plus A square minus AC minus B square and plus B into C. Here plus B square and minus B square will get cancelled. Minus AB and plus AB minus C square and plus C square. AC and minus AC. B into C and plus B into C. Minus A square and plus A square. Everything will be subtracted. So you'll get x to the power 0, which is equal to 1. So for 14th one, the correct option is A. Now question number 15. We have x to the power A divided by x to the power minus B, the whole to the power A square minus AB plus B square into x to the power B divided by x to the power minus C, the whole to the power B square minus B into C plus C square into x to the power C divided by x to the power minus A, the whole to the power C square minus AC plus A square. Now here the denominators I'm bringing to the numerators, so the sign and the powers will change. So this x to the power A will stay as it is, and x to the power minus B, when I bring it to the numerator, it will become x to the power B. The minus will disappear. The whole to the power A square minus AB plus B square into x to the power B into x to the power C. When I bring it up, it will become positive. The whole to the power B square minus B into C plus C square into x to the power C into x to the power minus A will become x to the power A. The whole to the power C square minus CA plus A square. Now since the bases are same, the powers can be added. So this will become x to the power A plus B into A square minus AB plus B square into x to the power, again the powers will be added, so this will become B plus C into B square minus B into C plus C square, and this will become x to the power C plus A into C square minus CA plus A square. Now to the powers, we'll apply the formula A cube plus B cube, which is equal to A plus B into A square minus AB plus B square. If we apply this formula to the powers, we'll get x to the power A cube plus B cube into x to the power B cube plus C cube into x to the power C cube plus A cube. Now again the bases are same, x into x into x. So the powers can be added. This will become x to the power A cube plus B cube plus B cube plus C cube plus C cube plus A cube. Now A cube and A cube will be added, B cube plus B cube and C cube will be added. You will get x to the power 2A cube plus 2B cube plus 2C cube. Now x to the power 2, I'm taking it out as common. So we'll get 2 into A cube plus B cube plus C cube. This is the answer, which is option number C. So for 15th one, the correct option is C. Question number 16. X to the power A square into B to the power minus 1 and C to the power minus 1 into x to the power B square into C to the power minus 1 into A to the power minus 1 into x to the power C square into A to the power minus 1 and B to the power minus 1 minus x cube is equal to 0. Here I am taking the minus x cube to the other side. And wherever there is minus in the power, I am bringing it to the denominator. So this will become x to the power A square divided by B into C. B and C has minus in the power, so I am bringing it down, and both has 1 as the power, into x to the power B square. Here C and A I am bringing it to the denominator. CA into x to the power c square, and here a and b, it has minus in the power, so I'm bringing it to the denominator. And minus x cube, I'm taking it to other side, so it will become plus x cube. Now take LCM. Now the bases are common here, so I'm adding the powers. You'll get x to the power a square divided by b into c plus b square divided by c into a plus c square divided by a into b is equal to x cubed. Now take LCM for the powers. You will get x to the power. The LCM is a into b into c. So whichever term is missing, you will multiply that in the numerator. Here in the denominator, a is missing. So multiply the numerator with a. So a into a square, you'll get a cube. Plus, here in the denominator, b is missing. So multiply the numerator by b. So b square into b, you'll get b cube. Plus, similarly, here c is missing. So multiply by c, you'll get c cube is equal to x cube. Now here, we are applying the property a to the power x is equal to a to the power y. Now, if the bases are same and is equal to each other, then the powers are also equal to each other. Here, the bases are same, x, and they are equal to each other. So, I am taking only the powers. A cube plus b cube plus c cube, the whole divided by ABC is equal to 3. Now, this ABC, I am taking it to the other side. So, we get a cube plus b cube plus c cube is equal to 3ABC. Now in the question they are asking us to find a plus b plus c. Now if we use the formula for a cube plus b cube plus c cube, the formula is a cube plus b cube plus c cube is equal to a plus b plus c into a square plus b square plus c square minus ab minus b into c minus c into a plus 3b, 3a, b, c. Here they are asking us when a cube plus b cube plus c cube is equal to 3abc. When a plus b plus c, here if we write a plus b plus c as 0, then 0 multiplied by this entire thing, whatever is inside the bracket will become 0. So we'll get a cube plus b cube plus c cube as 3abc. So the condition is a plus b plus c should be equal to 0. Only then a cube plus b cube plus c cube is equal to 3abc. So the answer is 0. Option number C. So for the 16th one, the option is C. Now 17th one. The question is z to the power z root z is equal to z root z, the whole to the power z. So here z to the power z root z is equal to, this can be written as z to the power 1 into z to the power root, I'm writing it as to the power 1 by 2. Okay, so whole to the power z. So here we'll get z to the power z root z is equal to, since the bases are same, the powers can be added. So z into z, z to the power 1 plus 1 by 2. I'm adding the powers. So whole to the power z. So this will become z to the power z root z is equal to, if you take LCM, you'll get, this will multiply by 2. So you'll get 2 plus 1 divided by 2, which is 3 by 2. The whole to the power z. Now this 3 by 2 and z I'm multiplying. So I'll be getting z to the power z root z is equal to z to the power 3 by 2 z. Now here I'm applying the property a to the power x is equal to a to the power y. When the bases are same and it's equal to each other, the powers are also equal to each other. So here it's z and z on both the sides and it's equal to each other. So taking only the powers, we get z root z is equal to 3 by 2 z. Both the sides we have z, we can cancel it. So root z is equal to 3 by 2. So z is equal to, if square root goes that side, it becomes square. So we'll get 3 by 2 square, which is equal to 3 square divided by 2 square. 3 square is 9 and 2 square is 4. So the answer is 9 by 4. Option B. 17th one, option B. Thank you for watching. If you like my video, click on the like button and don't forget to share. Also subscribe to our channel for more such videos.